We do margins and differentials. Next section, margins and differentials. First, recall that the cost function from the previous section was capital C of x, where x is the number of items. If we find C prime, so the derivative of the cost function will give us what we call the marginal cost of x items. And the marginal cost can be approximated by finding capital C of x plus 1 minus capital C of x. Same thing with the revenue. Revenue, capital R of x, where x is the number of items. If we find R prime of x, this is called marginal revenue of x items. So R prime of x can be approximated by capital R of x plus 1 minus capital R of x. Similarly, for the profit, capital P of x, so if you find the derivative of that, that's the marginal profit of x items, and it can be approximated using capital P of x plus 1 minus capital P of x. To apply this, let's say it's given that the cost function modeled by 10x plus 3, the revenue function 50x minus 0.5x squared. We're asked to find the profit, capital P of x. So remember how we defined the profit in the previous section is the revenue minus the cost. The revenue here is 50x minus 0.5x squared minus, don't forget to open parentheses. The cost function is 10x plus 3. What do we get for this? 50x minus 0.5x squared minus 10x minus 3. So that gives us negative 0.5x squared plus 40x minus 3. That's all they ask us to find for this part. Part B, they want us to find the cost, the revenue, and profit from 40 unit sale. 40 unit sale. So it means if you sell 40 items, so this means X is 40. It's all easy substitution. The cost is C of X, which is C of 40 here. And it's 10X, so 10 times 40 plus 3, 403, maybe in dollars. If you try the revenue, R of X was 50X minus 0.5x squared. All you have to do is substitute R 40. 50 times 40 minus 0.5 times 40 squared. And that gave me 1200. The last one here is the profit. So they want us to find the profit at 40. Remember, the profit is the revenue minus the cost. And the good thing, we found both of them. This was 1200 and the other one was 403. Subtracting, that gives us 797. Part C, we still need to find now the marginal cost, marginal revenue, and marginal profit when 40 units are produced and sold. Four units are produced and sold. So remember, the marginal profit is the derivative of the profit. Marginal cost is the derivative of the cost. So the cost function, if we look back at the function, was 10x plus 3. So its derivative is 10. So to evaluate this at 40, it's going to stay 10. That's the marginal cost. Marginal profit, we need to find p prime of x, which I did find it already, 40 minus x. And we are going to evaluate this at 40 when x is 4. So p prime at 40, that's 40 minus 40, which is 0. Same thing for the r prime of x is 50 minus x, marginal revenue, and we need to evaluate this at x equals 40. So r prime at 40, 50 minus 40, which is 10. Note something here. We know that p of x is the revenue minus the cost. If we differentiate everything, so p prime of x would be r prime of x minus c prime of x. If we try to evaluate at x equals 40, which we found earlier, the profit here, it was 0. Let's see if we get the same answer. P prime at 40 is r prime at 40 minus c prime at 40. R prime at 40, you see it was 10, and c prime 40 also 10. It still gives us 0. Gonna go over another example. So this talks about, let's say, weekly profit for producing X numbers of laptop computers is given by p of x negative 0.004x cubed minus 0.3x squared plus 600x minus 800 currently builds and sells 9 laptops weekly. Part A. What is the current weekly profit? Part B. How much profit would be lost if production and sales dropped by 8 laptops weekly? So they give us the profit function here. They want us to know the current weekly profit. Weekly profits, they want us to find the profit for a sale per week, which is 9 laptops. So they want us to find P of 9. So all you have to do is just substitute the 9 for x. 0.39 square. 600 times 9 minus 800, which I evaluated and I found it's $4,572.78. That's just a current weekly profit because they sell 9 laptops per week, and that profit function gives us the weekly profit for selling X items. Now they said how much profit would be lost if production and sales dropped to 8 laptops. Instead of 9, there's 8. So what we need to do is basically find the profit for selling 8 laptops. Again, same thing as the previous one, just substitute x8. And I calculated this and it gave me $3,978.75. So the profit that was lost is P of 8 minus P of 9, which is 4572.78 minus 3978.75. And that would be $594.03. So for every item, one less item they sell, they lose that much money. Let's add part C to this. What is the marginal profit when x equals 9? Marginal means you're talking about derivative. So what is p prime of x? That's what the question is asking. At x equals 9. So what do? We find the derivative for that, which is negative. You bring the 3 down times 0.04. That's 0.012 x squared minus 0.6x plus 600. That's the derivative for the profit function. And we need to evaluate this at 9. 0.012 times 9 squared minus 0.6 times 9 plus 600. And that would give us, calculation-wise, $593.63. And I highly recommend you try it on the calculator. Make sure your answer will match with mine. And one last part, we need to find or estimate the profit resulting from the production and sale of 10 laptops weekly. So here we're dealing with estimation. Remember, we give you a formula for estimation for each, the profit, cost, and the revenue. For the profit, P prime of X is about P of X plus 1 minus P of X. That's the one we gave you. And remember, X is given as 9. So if you substitute that in, is about P of 9 plus 1, 10, minus the profit at 9. So they want us to estimate for the 10. So if we add P of 9 to both sides, that gives us P of 10 is about P prime at 9 plus P at 9. Where am I going to get P prime at 9? We may scroll up, see P prime at 9. We just found it in the previous part. 593.63. 593.63. P of 9. Did we find P of 9? Let's scroll back up and see. The profit at 9, it's part A. It's 4,572 and 78 cents. You can substitute this in. 4572.78. And if we add them up, we get $5,166.41. That's the estimated profit for selling 10 units. Because originally it was given to us, if we sell 9 units per week, we get that much money. If we sell 8, we're going to be losing about 500 something dollars. But if we sell 10 units, we're going to make more money, more than the 4,000 something, 4,572 units. Make sure to add 20 exercise 25 and 27 to the homework. 25 from the textbook. So now we introduce some notation here. So we can always use, if you have a function f of x, we can use f prime of x to estimate f of x, value for x, as we did earlier. We did some estimation. So here, the first thing is If we look at, to introduce what differentials are, if we look at any function like this, pick any point on the graph of this function. Okay, this is x. If you move an h distance, this becomes x plus h. So project it up. This is the function f. If you project it on the y-axis, this gives f of x. I'll give you time to copy, guys. Watch this. Projected here, that's f of x plus h. Okay, so now this distance, the horizontal distance from here to here is h, and we are going to also call it delta x. So this is delta x. So delta x here is x plus h minus x, which is h. So delta x the same as h. If we call x x1 and the next point x2, so you can say delta x is x sub 2 minus x sub 1. Also, this is delta x. Also, this here, I'm gonna call it delta y. What is delta y? It's the whole thing minus this. So delta y is f of x plus h minus f of x. This is the change in the y. It's given like this. So this is the change in the y. So to see an example on this, find delta y if y equals, let's say 2x squared with x is 3 and delta x is 0.1. So very quick, for delta y, it's f of, define x plus h minus f of x, and remember h is the same as delta x, so it's f of x plus delta x minus f of x. This is f of x, the given function y equals. So let's see what we have. X is 3 and delta x 0.1 minus f of 3. Delta y is f of 3.1 minus f of 3. Two times 3.1 square minus 2 times 3 squared. I'm substituting 3.1 back into the function. Note that f of x is the given function, 2x squared. Now we can put all that in the calculator. And that gave me 1.22. That's delta y, the change in the y. Recall, we had what we call the difference quotient, f of x plus h minus f of x over h. Difference quotient. This difference quotient, we called it m, is the slope of the secant line. And this is the same if I take this at x equals delta x, h equals delta x. This is the same as the change in the y over change in x. It's rise over run. Rise over run. And we can then say the derivative, we express the derivative dy dx as the limit of delta y delta x, the slope as delta x approaches 0, means delta x is very small. So as delta x gets in closer and closer, we have, as delta x gets closer to 0, the approximations dy dx to be about delta y over delta x, or we can write it f prime of x. That's what dy dx, it's about delta y delta x. And from here, if you kind of like cross multiply, we get that delta y is about f prime of x delta x. So now we say for a continuous and differentiable function f of x, we have that delta y is about f prime of x delta x. And by definition, for y equals f of x, we define dy to be the differential of x by dx equals delta x, and dy, the differential of y, by dy equals f prime of x dx. And the last thing here to do is linearization. Linearization is just to estimate the function with its tangent line. So if we let y equals f of x be a differentiable function, at x equals a, the linearization of f at x equals a is given by f of a plus f prime of a times x minus a. This is the equation of the tangent line. To f at x equals a, to the graph of this function. So if they ask us to find the linearization of f of x equals the cubic root of x at x equals 1. So to find the equation of that, x equals 1 means a equals 1. When x is 1, y would be the cubic root of 1, which is 1. So I have the point 1, 1. This is f of a. This is a. Now from the function, we can rewrite it as x to the 1/3 because we need to find the slope of that. To do that, f prime, we need to find the derivative. It's 1/3 x subtract 1 from the exponent. 1/3 x to the negative 2/3. So to find f prime at 1, it's 1/3 1 to the negative 2/3. So 1/3. This is f prime at a. Now I use the formula f of a plus f prime at a, x minus a. F of a was 1. F prime at a is 1/3, x minus 1. And it would be nice to simplify this. You get 1 plus 1/3 x minus 1/3. Y would be 1/3 x plus 2/3 if you combine 1 minus 1/3. Now we can use this to approximate the cubic root of 4. So what we just did is f of x is the cubic root of x is approximated with this line that we found. Linearization came from a line. So if they want us, a lot of people call this L of x. If I want to approximate the cubic root of 4 with no calculator, I can substitute x equals 4. And that would give us 4/3 plus 2/3. That's 6/3, which is 2. Anyone has any questions?